Welcome to the video for chapter 1.1 and 1.2. This video is going to be all about statistics and data. Now, when you hear the word statistics, what kinds of things come to your mind? You might think of numbers, percentages, graphs, ratios. You might even think of things like averages. All these things are a part of statistics, and we're going to see them all as we go through this course. But let's start off with a definition here for statistics. For the purposes of this course, we'll say that statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions and draw conclusions. So data is going to play a big role here in statistics. We'll talk a little bit more about data in just a bit, but for now you can see that statistics is all about collecting data, organizing data, analyzing data, interpreting data, and we do all those things for a reason. We're doing them so that we can make some kind of decision or so that we can draw some kind of conclusion. Now, statistics is typically divided into two branches, and we're going to talk about both of these branches in this course. One branch of statistics is known as descriptive statistics. Descriptive statistics, if you look at that word descriptive, you could probably see the root word behind it, describe. Okay, so descriptive statistics is where we're describing various characteristics of a data set. We're going to learn how to describe several different kinds of characteristics of a data set in the first part of our course. Then towards the end of the course, we'll start looking at the other branch of statistics, which is inferential statistics. And you might see the word inference hiding there. Inferential statistics is where we study a sample and then draw conclusions about a population, or possibly make some predictions about the future. Now, sample population, we'll see these terms quite a bit as we go through the course. Generally speaking, a population is a group of people, or it might be a group of objects that meet some criteria. And the population would be all the people or all the objects that meet that criteria or fit that definition. So the word all is a key word there with populations. So if I said, let's consider all the people who live in the state of Maryland, that would be a population because I'm talking about all the people who meet this criteria of living in the state of Maryland. Or if I said, let's consider all the students at Baltimore City Community College. Again, when I use that word all, that means I'm referring to a population. Generally, populations are too big for us to study. There's just too many people or too many objects in them. It would take too much time, too much money, too much effort to study each and every person or each and every object that's in the population. So what we end up doing is we end up taking a small group out of the population and studying that small group. That small group is called the sample. And then based on what we learn about our sample, we try to go back and make some conclusions about the population from which we took that sample. Okay, so again, population, the key word is all. The sample would be a subset of the population, a small group that's taken out of the population. So we're going to learn about both of these branches of statistics in this course. The first part of the course is about descriptive statistics. The last part of the course is about inferential statistics. In the middle of the course, we're going to learn some things about probability. Okay, and we need to learn some things about probability in order to do inferential statistics, because whenever you study your sample and draw your conclusions, you're basically going to be saying, well, based on what I see here in the sample, there's a chance that the population looks like this, or there's a chance that this is going on with the population. When you start talking about chances, you're talking about probabilities. So we'll have to spend a few chapters in the middle of the course learning all about probability so that we can then do the inferential statistics towards the end of the course. Okay, now we said that statistics is all about data. So let's talk about data for a little bit. Data is information. Okay, that's the best way to think about data. It's just some kind of information, and we can classify data in different ways. One way that we can classify data is either qualitative or quantitative. Let me talk about quantitative data first. You might see the word quantity hiding in there. A quantity is something that is counted or measured. It's the amount of something. And the way that you get that amount is you either count something or you measure something. Now, if you count something, you can go one step further and call it discrete quantitative data. If you're measuring something, and when you're measuring something, you typically have some kind of tool like a ruler, a scale, a stopwatch, a thermometer. If you're measuring something, you'll have what's called continuous quantitative data. So for example, if I walked into a classroom and I said, I wonder how many students are in this class, I could start to count 1, 2, 3, 4, 5, 6. That would be discrete quantitative data because I'm counting something. Now, let's say I wanted to know how tall the people are in that class. Well, I might have to take out my ruler or my measuring tape and have each person stand up and I can measure their heights. Since I'm measuring there with a tool, that would be continuous quantitative data. Now, the other kind of data that we'll work with in this course is called qualitative data. And the word quality is kind of hiding in there. Qualitative data, these are going to be categories, labels, descriptions, these sorts of things. Anything that's not counted or measured is basically going to be qualitative data. Now, what I don't want you to do is I don't want you to get it stuck in your mind that quantitative data is numbers and qualitative data is anything that's not a number. That's not the best way to think about this, because there are some numbers that are actually qualitative data. Think about your social security number. That's a number, but it's not counting or measuring anything. It's a label. It's an identifier that identifies you. So we would say that social security number, even though it's a number, is qualitative data, not quantitative. Okay, so if you're trying to make that distinction between what's quantitative, what's qualitative, the best way to do it is to ask yourself, am I counting something or measuring something? If you are, that's quantitative data. If you're not, then you're dealing with qualitative data. And then, like I said, you can break down the quantitative into discrete or continuous data. Discrete data, you're just counting something, 1, 2, 3, 4, 5, 6, 7, 8, so on. Continuous data, you're measuring something, and that usually requires some kind of tool. So you measure people's heights with a ruler. You can measure the weight of suitcases with a scale. You can measure the temperature with a thermometer. You can measure how much time it takes to complete a task with a stopwatch. So if you see that there's some kind of tool involved, then you're most likely dealing with continuous data. Now, there's one more way that we can talk about data, and this is sometimes called the level of data, and there's 4 different levels that we can talk about. We have what's known as the nominal level, the ordinal level, the interval level, and the ratio level. So let me tell you a little bit about each one of those. Nominal data and ordinal data, for the most part, these are going to be qualitative data. Now, nominal data, we would say, are mutually exclusive categories where no order or ranking is possible. So that means you really can't sort this data in any kind of meaningful way. So for example, if we talked about people's eye color, some people have brown eyes, some people have blue eyes, some people have gray eyes, some people have green eyes. There's really no way that we can sort that in any kind of way from least to greatest or highest to lowest or anything like that. I mean, you can put it in alphabetical order, but that's really not any kind of least to greatest, first to last kind of ranking. If we talked about students' majors, you have business majors, you have nursing majors, you have psychology majors, you have music majors. Okay, we could have a list of everybody's major, but we really can't sort that from least to greatest, highest to lowest. Okay, there's really no way to rank it from best to worst, anything like that. So that would make this nominal data. Now, ordinal data, this tends to be categories that can be ranked. Okay, so for example, if we talked about the letter grade that you would earn in this class, A, B, C, D, or F, Okay, well, those are categories, but there is a ranking. A is better than B, B is better than C, and so on. Or if you've ever completed one of those surveys that say, rate your experience at this restaurant, or rate your experience with this service. Was it poor? Was it fair? Was it excellent? Okay, those are categories, and there's a way that you could rank them. Okay, it's better to get an excellent rating than it is to get a fair rating. Okay, it's better to get fair than it is to get poor. So you can rank those. That's what makes it ordinal data. If you know the ordinal numbers, right, the ordinal numbers would be first, second, third, fourth, okay, as opposed to the cardinal numbers, which are 1, 2, 3, 4. So the ordinal numbers, first, second, third, fourth, kind of suggest that there's a ranking there or a way to rank. So if you keep that in mind, it can help you remember what ordinal data is all about. Interval data and ratio data, these tend to be quantitative data. And the main difference here is that if the number 0 really means nothing, then you're dealing with ratio data. But if the number 0 doesn't necessarily mean nothing, then you're dealing with interval data. Okay, so we would say that interval data has no meaningful 0, where ratio data does have a meaningful 0 or a true 0. So let me give you some examples to help you see the difference here. An example of interval data would be temperature. Okay, temperature, if you know the way the temperature scale works, first of all, let me say that temperature is measuring how much heat is present. Now, if you know the way the temperature scale works, when it's 0 degrees Fahrenheit outside, that doesn't mean that there is no heat at all outside. And the way I know that is because if I take a little bit of heat away, I can actually get a temperature of -1 or -2 degrees Fahrenheit or -10 degrees Fahrenheit. So if I'm able to get negative temperatures, that means when I have 0 degrees, there's actually some heat there that I can take away. So 0 degrees doesn't mean no heat at all. That's what makes temperature interval data. Now, ratio data, on the other hand, when the value is 0, that means you have nothing. Okay, so for example, weight is ratio data. If something has a weight of 0, that means it doesn't exist. Okay, or distance. Okay, if distance is the amount of space between two objects, if that distance is 0, that means there is no distance between those objects. So when 0 really means nothing, then that's ratio data. But if 0 indicates that you still have some of whatever it is present, such as heat when we're talking about temperatures, then that would be interval data. Okay, so that's an overview of section 1.1 and 1.2. I'll see you back here for the next video where we finish up chapter 1.